Myself, Dr. S.P. Deshmukh, Department of Chemistry, DB of Dayanand College of Arts and Science, Solapur. Today we are focusing on the topic of HSAB, that is hard and soft acids and bases. So first of all, we have to know what it means by acids. There are a number of definitions are present in the literature, what mean by acids and or what mean by base. But with respect to that, we have to see the majorly in the context of Lewis acids and bases. So Lewis acids are electron pair which are having ability to accept that electron pair. It is also we call as a electrophile. While Lewis bases are electron pair donor and it is also we call as a nucleophile. So whenever there is a neutralization takes place, at that time there is a having reaction between acids and bases. So here is one simple example between NH3 and BF3. BF3 act as an acid and NH3 act as a base, and we get the final product of other. So we firstly understand what are the different characteristics of acids and basically bases, in which we firstly see the different characteristics of hard acid and soft acid. So hard acids are having the smaller in size, they are having higher oxidation state, they are having also absence of d electron, and therefore they are lower the valence electron. Also these are hard acids are light metals. In the angle of soft acid, when we have to see its own characteristics, they are again larger in size, not only large in size but also having lower oxidation state or zero oxidation state. There are number of valence electron. This is due to the only presence of d electron. So we have to see how it is work in this context. So we have to again go in this slide what are the basic characteristics of different hard acids and bases, soft acids and bases. So these characteristics gives an idea about the how it is work and why we are thinking in this angle of HSAB concept. So firstly we know the hard acids are having the low polarizability, higher the positive charge, smaller in size and not easily oxidized, while hard bases are in complementary to that, that is a low polarizability, spread donor orbital with having more electronegativity and not easily oxidized. When we have to see the soft acids, at that time soft acids are high polarizability, low positive charge, larger in size and also easily oxidized, while soft bases are high polarizability, diffuse donor orbital and also low electronegativity and easily oxidized. So what we getting from these characteristics? These characteristics gives an idea about the how there is a different inorganic compounds are formed and what are the way of stability or stability of that concept we have to get it with these characteristics. So this is the picture of a periodic table and with having different types of acids and bases, hard and soft also. So this periodic tables gives an idea about the position of different types of hard acid and hard bases, similarly soft acids and soft bases, and also borderline acids and bases. So in periodic table we have to see the picture in which left hand side alkali metal, alkaline earth metal and some first 2-3 elements of D block, they are showing hard acids, basically hard bases also if they are having negative in charge, while some of them having represented in yellow coloration, that is a borderline acids and bases, while other form which we have to see the electronegative elements basically show soft acids and soft bases. There are some different examples, like the hard acids are having lithium, sodium, potassium, beryllium, magnesium, while soft acids are palladium, cadmium, platinum, mercury, copper, plus they are having positive charge, while hard bases are having negatively charged, with hard bases are having more electronegative while soft bases are having less electronegative. and also there are different characteristics which we have to see here. Then we see the how the Pearson explain this concept, that is a way of formation of different types of any compounds. So in that concept we have to know the how the formation of these hard and soft bases. So generally hard acid prefer to bind with hard bases, while hard acid not prefer to bind to soft bases. So this picture gives an idea about the how it is work. So here is one table. That tables gives us a idea about the formation constant of halide ion, in which hard and soft and intermediate metal ion. So in that table, the K, log of K, represent the formation constant, and it tells us the soft interaction and hard interaction. It means that hard acid prefer to bind with hard bases, but it is not bind with a soft bases. So this idea we have to get in with this Pearson concept. Then we have to see this another one idea about this increasing and decreasing of trends of hardness and softness. So in periodic table we have to see from the group of 4th, 5th, 6th, 7th of non-transition elements. So carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic like to be in vertical group. So we have to see the silver plus ion having preferably bind with having halides of chlorine, bromine, iodine to the fluorine minus ion, while because silver is soft acid, while hard acid of Fe3 plus ions having preferred to bind with having lighter fluorine atom. So that way we have to get it an idea. While in case of intermediate lead ions does not show any strong preference either way. So this gives an idea about the how there is a basically interaction with hard and soft of acids and bases. Then this is the one typical example, or what we call as the application of HSAB. In that application what we are getting, the complex would be more stable when there is a having the metal and ligand both are having harder side. So stability of complex can well explain with respect to this complex, this HSAB principle. How? I will tell you. So AgI2 minus is stable than that of AgF2 minus. So what is the reason behind that? If we see AgI2, when it is ionized, when we have to ionize it, it form Ag plus and 2 ion minus. So Ag plus is soft acid and iodine is a soft base. So there is a soft acids and bases interaction which leads to more stability of the complexes. While AgF2, when it is ionized, there is a formation of Ag plus and 2F minus. Ag plus is a soft acid, but F minus is having hard base. And so there is interaction between soft acid and hard base leads to instability. So this is the way of idea about how there is a having we are getting stability of the complex or not. Here is also one another example, COF6 3 minus and COI3 3 minus, in which cobalt plus ions is hard acid and F, as we seen, F minus is hard base and I minus is soft base. So hard acid base interaction leads to COF6 3 minus is more stable compared to COI6 3 minus, because there is having hard acid and soft bases. So this is the way of understanding stability of complex with respect to this HSAB concept, and this is the one of the simple way of understanding that ambidentate ligand. Ambidentate ligand means the ligand which having ability to bind more than one atoms. They have coordinate through one or more atom in that ligand. So SCN, in which S also N acting as an ambidentate ligand. They have monodentate ligand but having ability to coordinate through sulfur also and nitrogen also. That would be happen with respect to this way. Then we have to see the how we have to classify these acids and bases. when we have to classify it, there are we have to see some preferences for reactant. So here the example which is given, that base B is classified as a hard or soft based on its equilibrium constant. So in this reaction, so we have to BH plus CH3Hg, which used to be here arrow, and then CH3HgB plus and H plus. So here is a competition between acids H plus and CH3Hg plus. So if B is soft, then it moves to be right. If it is B is hard, then it is moves to be left. What it means? The ability to interact with a hard to hard and soft to soft acids and bases. So this gives an idea about that we have seen that hard and softs are relative to each other, and this is the way how we have to get it. Then next one, occurrence of ores and minerals. This used to be different types of hard acids and minerals. Mg plus 2, calcium plus 2 are occur mostly in their oxides, carbonates and halides. While some metals are poisonous because of presence of other metal. So poisoning is attributed due to soft acid soft base interaction, but soft metal and soft ligand also playing crucial role. So in this case, these ligands strongly adsorb on the surface of metal and block its active site, and that way they have to poisoning the metal ion. And generally, soft acids are not affected by hard bases of ligand containing nitrogen and fluorine. So in this angle, we have to understand what are the different theoretical bases of this hardness and softness. So pi bonding theory, Witzer theory, electrostatic interaction, these are the different theory. Pi bonding theory explains how there is a soft interaction on the basis of pi bonding playing major role for its stability. So polarization of soft acid and soft bases mainly favor pi bonding. Secondly, Witzer London theory explain the different energy which leads to stabilize two larger polarizable atoms, and the energy increases with increasing size and polarizability. So that is the why soft interaction is more stable than that of a soft and hard interaction. And the next one, that is the electrostatic interaction. Hard ion interaction is purely ionic, purely electrostatic, but that interaction, that is a force of attraction between oppositely charged ion, is proportional to internuclear distance, that we have to know. So these electrostatic interaction playing major role to get the stability of that complex. Then polarizing power is one of the key aspects for this HSAB concept. Covalent bond is formed by the soft acid and soft bases, but soft acid and soft bases, suppose they are having larger insides, and their polarizing effect will be explained with respect to interaction. So these metal ions are having d orbital and d electrons, and these subshells can having ability to polarize easily, and therefore they have to show more stability with respect to soft acids and soft bases. In addition to that, electronegativity of these elements also playing major role. So species with higher electronegativity are hard, like to be fluorine is a hard, while iodine is having soft because of low electronegativity. So with respect to electronegativity, we have to understand the hardness and softness. In this, CF3 considered a harder than CH3 because fluorine is more electronegative than that of a hydrogen. BF3 is harder than BH3 because fluorine is again more electronegative, and therefore this is hard one. And this is the strength between them, strength playing crucial role with respect to softness and hardness. So this is the reaction which we have to understand how the strength playing. So soft hard, hard soft, so interaction, and there is a displacement, and when K equilibrium is greater than 7 or equal to 10 raised to 3, it uses interaction between hardness and softness, and with respect to this idea. Then with these idea, we have to go lastly with what are the limitations. So limitation of this HSAB concept has different types, because there are having strength of acids are not accounted with respect to. they are having fields to keep parity with acids and base strength. So there are having some practical what we call as a limitation with respect to this HSAB concept, but it gives a major breakthrough with respect to these ions. So with these idea we have to stop here. We thank you so much.